Hey everybody, welcome back to the channel. Still working on the two-wheel drive dual CVT mini bike build, trail bike build. Off camera I got a couple wheel hubs built. So today we are going to put the bolt hole circles in them. And we're also going to build from scratch a hub to hold our brake disc. I've got the perfect little chunk of steel here. A really good buddy of mine gave me a whole bunch of random odds and ends of steel. This is 1045, so it's a decent quality steel. Not exactly sure how this is going to machine, but we're going to find out. Got myself a rudimentary little drawing here. This hub is going to be an inch overall long. The part with the bolt hole circle in it is going to be 2.5 inch diameter-ish. Might take a little more, might be a little smaller by the time I clean that material up. This is going to be the area where the brake disc sits. And of course it's going to have a 1-inch bore through it to fit the axles on the bike. It's going to have a set screw threaded hole in it, and it's going to have a bolt hole circle, and that's going to be tapped out 1/4-20. So just going to throw this in my 3-jaw chuck, and the first thing I'm going to do is face the end of it up nice so I have a surface to start referencing all my dimensions from. So I've got a dial set where I want to stop my travel for this cut, and I'm really going to minimum skim this thing because it's just over 2.5 now. It's not critical that it ends up at 2.5, but it's always nice to just end up at nominal numbers when you can. That's clearly not clean enough, but I'm going to go ahead and let this pass finish, and we'll take another small pass once I see how far along it's coming. So that's my outside diameter done. I'm just going to touch off in the face now. I'm going to get my dial reading off the carriage, off the table. I'm going to advance it probably 10 thou shy of the length of spigot that I want to put on here, and then I'm going to start roughing the diameter down. And then I'm going to set this dial so the first time it comes around 0, that'll be where I stop on these roughing passes for my spigot. And we're ready to make some chips. Got this spigot finished to length, and I'm super happy with the fit. I'm going to start by drilling out a hole for the 1-inch bore that's going to go in this thing. Actually, I'm going to begin by center drilling. Just getting set up to do that now. I'm just marking my drill here so I can stop at approximately the depth I want to. Any extra hole I make in here is just going to waste perfectly good leftover material. So I don't want my hole to be shy, clearly, but I also don't want it to be overly deep. I'm working my way up in drill bit sizes. I've got, well, I don't know exactly what size that was, somewhere in the neighborhood of 3/8. Now I'm going to go up to 3/4, and then from there on, I think we're going to bore. This bore is going to be 1 inch long finished, and I do want it finished past where my part off tool is going to run. So I'm at 1 inch 300 thou there. I think that's just about perfect. So I'm going to set up for boring. I do need a way of knowing when I'm at the bottom of my bore and stopping at the same place every time. So what I've done is I've touched off on the edge in the inside of my hole here with my boring bar, and then I've backed it up a little so I'm not dragging it along. Now I'm real gently going to go in till I feel where the drill stopped, where the point stopped. There it is there. Now I'm going to set my dial up and set a 0 right there, and that's where I will stop my boring. My bore is good. I might want to tune it up just a wee bit with some emery later, but for now it's good. It certainly doesn't need more machining. Now for the scariest part of this whole thing, it's parting this thing off. I've had some absolutely horrible experiences with parting things off in the past, and I'm a little gun shy of parting off. Now this is a 3/4 inch depth of cut. That does not add to my confidence any. What I'm going to do is I'm going to start into it. We're going to see how it's going. If it looks sketchy to me, if everything's bunging up on top of my tool, I'm going to stop, hopefully before I hurt anything, get this in the bandsaw. And I'm not parting exactly the size. I've left an extra 25 thou for facing later just because I expect there to be some scoring in there and so on. So I'm going to give it a try here, a very tentative try, and see what happens parting this thing off. Yeah, I'm just going straight to the saw. So it was just starting off by chattering like crazy. By the time I get this turning slow enough to get that chatter under control, this machine isn't going to have enough power to turn it. It's going to electronically trip out, and nothing worse than stalling with the tool in a cut. So rather than put myself through this torment and possibly hurt my machine, I'm just going to go ahead, set this up in the bandsaw and cut this off. So I'm happy to be sawing this off. That's in there, super secure. Things almost never go tragically wrong in the bandsaw. When I was a young apprentice, I was parting off. Of course, I was doing it all wrong. I was hanging on by just a little bit. I had outside jaws and a 3-jaw holding this part, and I was trying to part it off way too far from the chuck. Everything went sideways, ended up actually breaking a jaw completely off, firing the part across the room, ruining it. Definite terrifying moment and egg on the face. So I'm just going to throw this back in here now, and I'm going to face it down to size. This isn't a critical dimension. I just randomly picked that I want this thing to be 1 inch long, so the bore is 1 inch long. I think that'll give me an excellent fit on the 1 inch diameter shaft, good and stable. But we're going to shoot for as close as we can. So now before I get too close to my finished size, I want to make sure that this is running pretty darn true, because I'm going to be relying on this surface being true to everything else to put my bolt holes pattern in there. And she's pretty much bang on. So that's awesome. And I have 40 thou to go. I'll do that in 2 20 thou passes, I think. You always want to be super careful sticking your finger in a hole in the lathe like this. You basically, you want to make sure the hole is significantly bigger than your finger so that your finger can't get jammed up in there and twist off. That's done now, and all that's left for me to do on this piece is to put the bolt hole circle in. So I'm going to set my rotary table up. I have this hub and the 2 for the wheels. So I'm going to be a minute. I've got some cleaning to do. I've got to make a whole new, brand new setup. So rather than make you guys suffer through that, I'm going to do that off camera, clean up a little bit here, and then we'll come back and we'll pop our bolt hole circles in. I'm working on my setup here, cleaned up-ish, and what I want to show you guys is I got this rotary table with the Smithy lathe mill drill, and it's got a Morse taper in the middle of it. And what I wanted to do was be able to use this 4-jaw chuck on my rotary table, and you could tell it, you really couldn't use it as it is. So I built this adapter plate that clamps to the rotary table, and has a really accurate fitting spigot on it for the 4-jaw chuck. So this just goes into the Morris taper. That's in there. And then this drops on. It's a very close fit. As you can see, it needs to be all wiggled into place. Maybe needs to be a little cleaner. There we are. So now that's centered in, and there's zero wiggle in there, so I can confidently clamp this down with no extra effort, and I know my 4-jaw chuck's going to run true. So before I go through the time and effort of dialing this in this 4-jaw chuck, I want to make sure I've got adequate height here. This thing, as you can clearly see, it eats up an awful lot of height, and this is maxed out. This doesn't get any higher. And the issue is going to be that when I put my drill chuck in there, there's going to be nothing left for a drill bit. Let's see if you can see that. But the drill chuck would sit about there. All this stuff is all the way up. I could center drill probably just, but as far as drilling goes, I'd be out of luck. So that's not going to work. But luckily, I do have a plan B. This little drill chuck was given to us by one of our viewers, and it has a 1/4-inch nominal shank size. I do have a 1/4-inch collet that'll fit in here, so that little guy will sit about like that, and I've got all the room in the world to hold my center drill and my drill bit to do this drilling. Just using my edge finder here to find all the edges and get this thing centered up. I'm all largely set up. My part is in position. My part is dialed in my 4-jaw. I'm centered, my spindle is centered over where my first hole belongs. But up until now, I've been working on 2 assumptions. The first, that this was a 1/4-inch shank, and the second, that this chuck could hold a 1/4-inch drill, or specifically a 200 thou diameter drill is what I need for the 1/4-inch holes I'm threading into this part. Turns out this is a metric shank. I don't have metric anything here, so I can't hold this in this spindle. And I also can't get the drill size that I need into this thing. So I'm going to see what other solution I can find to hold both a center drill and a 201 thou drill bit in this spindle to make these holes. I've got a whole bunch of these sleeves, all different sizes, which I've made over the years for different things. Now, none of them are actually going to just up and work for this, so that's unfortunate. But I do have one that's very close. It's just under the size of the metric shank on that little drill chuck we looked at. So I've got the drill chuck set up over here. I've got a really super accurate 1/8 collet holding a solid carbide center drill in the collet, and then I've clamped this chuck down on the center drill, and it runs pretty darn true. I've got my fixture dialed in this way. I'm going to dress this wheel up. I'm going to see if I can't clean this shank up and get it to fit in this bushing. The OD of this bushing is 3/8. I do have an R8 collet that holds 3/8, so I might just be able to still use this drill chuck. And then I'm going to take a drill of 201 thou diameter. I'm actually going to wrap some paper around it, make a couple laps of paper. This collet's 18 thou bigger in diameter than the drill bit I need, but I think I should be able to reduce a shank slightly so that it fits in that chuck. That way I can center drill my hole, and then I can drill my hole prior to tapping. Now, with the paper wrapped around, it's not going to run dead nuts true, but when I center drill the holes, they will be dead nuts true, and the drill will follow the center drill, and so my holes should end up being exactly where I want them. So it's a lot of extra screwing around that I hadn't planned on, but I'm not just giving up. I'm not throwing the project away. This hole's getting made whether it likes it or not, and this is what I figure is going to be the easiest way to do it. So here we go. In the event that this shank doesn't clean up to suit this bushing, I do have the option of bringing that shank down in size to 3/16, the next nominal size, and I do have a collet for that, and so that would also work to get this done. So I managed to get this shank of this little drill chuck cleaned up to match my bushing. Fits pretty darn nicely on there. That should run decently true when I squish this in a 3/8 collet. So I think that's going to work for me. The next thing I'm going to do is try and reduce the shank of 201 thou diameter drill bit in order to make it fit in that chuck. So we'll see how that goes. All right, precision paper installation. There we go. See, guys, the thing about this is the dial's not going to lie. When I tighten this down in here and give it a spin with the dial on it, we're going to know exactly how much it's running out by, and then we can decide, is that adequate or not? And that's before ever having taken a cut, buggering up a perfectly good tool. So let's get the dial on it, see what it says. I'm comfortable with 2 thou. So the drill is going to flop around by 2 thou. I don't mind that. It's going to find its way to that perfectly drilled center hole, and the center hole will guide it. The other end of it can flop around by 2 thou all at once. That's not hurting us any. So I think I'm ready to roll again here, guys. I got, this is a 3/8 OD bushing. This drill chuck fits real decent into there. My drill bit now fits into the chuck. I've reduced that shank slightly. So I think we're good to go. So we're ready to go. This is a solid carbide center drill, 1/8 diameter. It's held in a really good condition 1/8 R8 collet. So that's going to run bang on true. Now, one thing that I learned years and years ago, and I really believe in it. So I'm just going to share it with you guys now. And this is a 6-hole bolt circle. So I can just use the graduations on my rotary table. I don't have to do any dividing or anything fancy like that. But even still, there was a bunch of math went into where my center distance is. And then I'm going to have to go around and find all these, every 60 degrees, there'll be a hole. Anyways, what I'm trying to say is I'm going to just put a dot all the way around and with the center drill. Then I'm going to come back, I'm going to measure, I'm going to confirm that I'm creating the right diameter bolt hole circle, and because that's super critical. And now if I was dividing this, it'd be even more critical, because if you get that math wrong, you could bugger up your whole part. You won't even know till you're back around to where you started, hours and hours later. So I think for the amount of time it takes, this is a super great precaution to take. So I've confirmed that this is correct, both by measurement and just by eyeballing. These holes are only 5 thou bigger than the bolt size that goes in there. So these need to be pretty bang on if they're going to work well for me. Since I already have a 1/8 collet in there, and I do happen to have a really nice brand new 1/8 drill bit, so I'm going to go ahead and blast all those holes through at 1/8, and then we'll put our Frankenstein's monster in, and we'll bring it to the final size. I've got the 1/8 holes all the way around now. I'm going to come back, with our Frankenstein drill bit sleeve chuck combination and finish these tap holes off. As expected, you can probably see that flopping around a wee bit, but it doesn't matter. In my mind, that's just going to follow that 1/8 hole through there just fine. So let's see what happens. I've got this 1/4 inch 20 tap and a 1/4 inch collet, and as I'm sure you're all aware, 1/4 inch tap measures ever so slightly bigger than 1/4 inch, so it's not going to be running bang on exactly perfect in there, but I figure it's still going to be way better than I could do just by hand and by eye as far as getting these holes started off nice and straight. So I'm going to start each of these 6 holes, get them on index, and then I'm going to take this out and probably finish the threading of the holes on the bench. No, I'm just going to deal with it.
Go on, show me.
All right. Up until about a second ago, my theory was to drive this tap like this. But then this happens as I approach my workpiece. And that's fine. I'm just simply going to grab myself a deep socket and we're going to use that. I only really need this tap in a couple of turns, you know, to get it lined up, and then I can do it by hand and it'll be fine. But I am stopping and breaking the chips here because I don't want anything going sideways on me at this point. So I'm actually not going to finish this on the bench because it's held so well. It's right here. It's at a perfect height. So I've just moved it out from under the spindle, and I'm going to finish these holes off by hand. They're guaranteed to go nice and straight now, so there's no longer any fear of tapping crooked holes. I'm just countersinking these holes, get rid of the burrs that the tapping is leaving behind, and I'm going to countersink them. Of course, that's going to make its own burrs and bugger up the top of my threaded holes ever so slightly. But then I'm going to run my bottoming tap in, which I have to do anyways because I can't get my plug tap through all the way. And so this way, everything will remove each other's burrs and I'll end up with some nice burr-free holes. So this is where we check the precision of all this work, and the proof will be in the pudding. You can see these holes, there's only 4 or 5 thou over the bolt size, so there's pretty much zero room to be wrong. Now I'm really hoping and praying that all these go in without interference. There's 3 out of 6 and no problems so far. 2 to go and we can be happy. So they're all starting, no problem. And there's still the slightest little bit of wiggle. Only 1 thou or 2 left of wiggle. If we'd have been out anywhere 3 or 4 thou more than we were, we'd be having troubles right now. But we're not, so it's awesome. I've got 2 things left now until this piece is done, and what I've set up for now is the set screw that's going to push down on the keyway. Now the set screw hole needs to miss the mounting holes, of course, and because I'd like it to be, you know, kind of centered, just looks better, a little pride and workmanship, I've taken this piece of high-speed steel here, and I've screwed 2 bolts into 2 of the holes and set that down on the high-speed steel so that this piece is basically leveled across these 2 holes. Then I've used my edge finder and I found center of the piece this way, and then used my edge finder to find center of the piece this way. So now I know I'm dead center of those 2 holes. Now this isn't going to be perfect, but this is going to get well within what anyone can see by eye as far as being centered. So I'm going to be happy with that. I'm certainly going to miss these holes. So now I'm just going to go ahead, center drill, drill, and tap. And then only thing left after that is the keyway. Now this is a 1/4 inch keyway. I've cut 3/16 keyways in this lathe before, and it was telling me, it was screaming to me, that's all I want to do. And that was in cast iron, which is pretty soft and forgiving. I'm not even going to attempt to push this thing to cut a 1/4-inch keyway. So I'm going to bring these 3 hubs into a local machine shop next week and see what sort of estimate they give me on doing this. And depending on, the price, I'll be deciding whether I want to buy some keyway broaches and do this work myself, or if it's going to be just more cost effective to have the odd key that I get cut on an ID done by somebody else. So here's our hub all done. Pretty happy with the way it turned out. It fits well on the shaft. Threaded holes are quite accurate. That set screw thread worked out. Spigot fits good. So now I'm just going to put it together here, and we'll put it up on the axle and see how she looks. I'm just test fitting this first hub. So far, so good. Seems happy in there. And one thing that makes me extra happy is it's 3/8 holes in the hub I made, and it's 3/8 holes that I drilled in the rim. They were metric, ever so slightly smaller than 3/8. So I opened them up to 3/8, and after all that, these 8 3/8 holes all align very well. So that's fun. Something about like that. I've never even pulled the caliper that came with this out of the bag yet. I'm going to grab that, see how that looks. Not entirely sure at this point how I'm going to position this, but it's going to have to go the other way. Anyways, going to have to figure all that out and then find a way that I can route it. The hydraulic line on this is just incredibly stiff. A little surprised by that. Might be a matter of putting it, yeah, something like that would probably work. Just some brackets coming off of here. Now, if I did want it on the back wheel, I wonder if there's even enough line here to get it all the way. Because there's way more than enough at the front. That'd be tight. I think I'm going to have to put it on the front. I'll just have to work on the orientation of it and then route it in a way that all the excess goes somewhere and doesn't look goofy. Well, thanks for watching, everybody. That's going to do it for this video. Huge thank you to our Patreon members, and we'll see y'all in the next one. I need to do that.
I think we're good.
Spin the wheel, spin the wheel.